The Black Mamba is our robot for this season of Beta the First Tech Challenge Romania. It is designed to accomplish all the tasks of this year's game theme, and it did even more. This robot united us as a team and a family and taught us to have patience and continuously innovate our ideas and systems until we were sure that we achieved our maximum potential. But let's get into how it is built. The base part of our robot is the chassis, which uses 4 motors with 435 RPM, each of them actioning a mechanism wheel. That is a wheel which uses rollers so that they could allow the robot to rotate in any direction in place without having to move. By using this, we can fully make use of the entire field and have an easier access to any part of it and to the game elements. The next system is the intake system, meant to collect the stones inside the robot. We managed to do this using 2 motors with 435 RPM. Each of them is connected using gears to a shaft on which there is a 4-inch compliant wheel and also a cog wheel connected to a second shaft, of which there is a 2-inch compliant wheel with plastic chain. The second shaft is sustained and connected to the robot by a 3D printed part on which we also hot glued a magnet and another one on the chassis so that the system would have a fixed position during the game. After the stone enters the robot, it gets into another 3D printed part which is a waiting point for it and a system transfer part. As from there, it is grabbed by 2 servos which have a 60-degree movement in 0.14 seconds using 8 cm long L-beams on each one of them. This entire catching mechanism is mounted on a 3-low U-channel profile system that is actioned by another servo using a drum and string, which is mounted in a cascading mode so that the entire system would move twice as fast as it would with a continuous mounting. To actually lift the stones upwards, we had to build another system which we call the lifting system, and it's the one that we are most proud of, as it is a 2-part system, meaning that it is built symmetrically on both sides of the robot and it consists of 6 25 cm long V-channel profiles that slide on each other using 3D printed sliders. This entire system is also stringed, but this time in a continuous way as it is safer for a vertical movement. To actually move the system, we were using an 1150 RPM motor with a 24:1 ratio worm gear assembled to keep the system up without having to continuously power the motors. The final and easiest part of our robot was building the platform moving mechanism, which only uses 2 60-degree movement in 0.14 second servos and 2 7 cm long flat beams with cheddar on them so that they would be more stable and have a stronger grip. This was our robot's journey for this season. If you want to find out more about us, check our social media info.